Hello, everyone. We still have people joining, and so you might see additional people trickle in. Welcome. This is the IndySCC at SC25 Jetstream2 webinar. I'm really glad to see a lot of familiar names and different teams represented here. What we're going to do is I'm going to just kind of give you some quick updates, introduce Zach, and then turn it over to him. And we should have plenty of time today for questions related to Jetstream2. So a couple of kind of logistic things. At this point, everyone should have access to your Jetstream2 allocations and be able to control your own instances. So create them, shelve them, unshelve them. I was able to confirm access IDs for everyone. You should also be added to the IndySCC at SC25 Google group. And to the greatest extent possible, we'll use this as our form of communication going forward. And so announcements, notifications, reminders, that sort of thing. If you do have something, sensitive to email the committee about that you don't want everyone else to see, that is totally fine to go through the IndySCC mailing address, which just comes to members of the committee. Or if it's very sensitive, you can email me directly, layla.freeborn@colorado.edu. I think that's it. I guess the one other reminder is that on August 12th, we have the SST webinar coming up. And so that's where you'll learn about the application, how to run it, and get some hints about what's coming with the homework, or I should say the exercises and the competition tasks. And just as a reminder, I'm aiming to have those exercises available to you all around August 25th. That's our target date. It might be a little bit sooner, it might be a little bit later. It just depends on how much time the app experts have available to develop them outside of their day jobs. But we're staying on top of it and getting those ready for you. So between now and when those exercises for the climate emulator and SST become available, you should be focusing your time on kind of familiarizing yourself with Jetstream2, maybe compiling SST and ECE, thinking about your benchmarks. So I think that there's plenty for you to do between now and when the exercises are released. With that, I will turn it over to Zach Graber, who works on the kind of infrastructure team for Jetstream2, and has been a devoted committee member for the IndySCC for the past couple of years. Zach's going to tell you all about, kind of the basics of Jetstream2, what to expect for what your resources look like, and any kind of gotchas that you might need to think about between now and the final competition. So Zach, I'll turn it over to you.
Awesome. Yeah, it's good to be here, and on behalf of the Jetstream2 team, I think we're very happy to be able to host the IndySCC again this year. We did last year as well. It's great to have the free compute cycles to be able to donate towards it. I think it's a great cause. But yeah, so my name is Zach. I work in a department called Research Technologies at Indiana University here in Bloomington. And I primarily work on Jetstream2. And so today I'm going to tell you a little bit about it, some more details about this year's competition and IndySCC specific things. Before I start, I did want to say if anybody has any questions along the way, maybe go ahead and raise your hand in Zoom with the little raise hand feature, and we'll see if we can address them along the way or take them at the end. So what is Jetstream2? Jetstream2 is a cloud computing environment primarily funded by the National Science Foundation, the NSF here in the US, under the Office of Advanced Cyber Infrastructure. And through that support and through the allocations ecosystem of access, which hopefully you're all familiar with by now, hopefully most people have accounts set up by now, um, we're able to provide kind of zero cost computation and these cloud resources to PIs who are based in the US and doing nonprofit research or education. Our system is comprised of about 67,000 CPU cores, 300-ish terabytes of RAM. We have 488 GPUs, so 360 of those are A100 40 gigs. 96, I believe, are new H100 80 gigs, and we have a handful, 32, I think, of L40Ss. A bunch of storage, which we'll talk about storage later, but everything the IndySCC teams will be interacting with will be NVMe based. And the primary method for accessing these resources is through something called an instance or a virtual machine. So if you've used a commercial cloud provider, I'm sure you're familiar with this idea where you can go in and you can create, if you've heard the term instance, virtual machine, virtual private server, those are all kind of the same idea. Um, and for this competition, you'll be interacting with our AMD Milan 7713s and either partial or whole NVIDIA A140 gig cards. And again, we'll talk about GPUs, we'll talk about slicing, all sorts of stuff later. In terms of networking, we are limited to 100 gigabit per second Ethernet between compute nodes, so hypervisors, and our leaf switches. So if you're looking at internode communication or communication outside of the IU data center, 100 gigabit per second is going to be your upper bound there. It's important to note Jetstream2 is not a traditional HPC cluster. So, A, in the sense that there is no central scheduler to submit to the way you would, log into a managed system and just submit your jobs to Slurm. Um, but in addition to that, we have other caveats that kind of make the Indie SCC a little bit of an edge use case. For example, we have no resource placement guarantees. So when you create an instance, this virtual machine, we can't guarantee that two instances would be placed on the same hypervisor or even near each other in the data center. And even down to the core level, we can't guarantee that CPU cores, for example, would be consecutive or on the same complex. And again, there's no ultra high performance network fabric like you'd see on an HPC cluster, so no InfiniBand, no OmniPath. Who operates Jetstream2? Jetstream2 is primarily operated by Indiana University, but we do have partnerships with a lot of other institutions. The ones you see listed here are partners that actually have availability regions, so they have smaller systems in their data centers. But we do have other partners as well who do things like outreach, software development, support, that sort of thing. But again, you can see that primary infrastructure at Indiana University, where everything you'll be running will be in our data center here in Bloomington. Um, and of course, everything is connected through kind of partnerships with research networks and institutions like Internet 2. So what are IndySCC teams going to get on Jetstream 2? It's important to note that much of this is not final, and compared to last year, the structure of this is a little less defined because of the nature of teams having access to control their own infrastructure, which we think is a great thing. But I did kind of want to give you an idea of what to expect in terms of kind of the scale of resources that we hope to provide you. And of course, some of these may have to be adjusted as we move through the semester due to availability constraints or due to kind of the nature of competition tasks, that sort of thing. Jetstream 2 is a large system. We do have a very large user base. And so as the semester goes on, we see usage fluctuate quite a bit. And so availability might change. So for the three kind of main phases of the program, not including in between time where you will still have access to resources, um, during this first phase, this exercise and prep phase, the recommendation we're making is to go kind of no higher than a head node with a handful of cores, a handful of compute nodes, and then we're hoping to give you access to at least one GPU compute node. And that is going to be a portion of an A100. In the very next slide, I'll talk about how that works. But we use a technology called vGPU to slice physical cards into virtual devices. And so your instance will see a GPU, but under the hood, you're receiving half of that card, that physical card. For the next phases, your hero benchmark runs. This is kind of where things scale up a lot, and we hope to give you access to a couple hundred CPU cores to really increase kind of parallelism there, and you get to make big benchmark runs. That's to be determined. And then for the final competition, this is going to look a lot like the prep phase, except we're hoping to scale it up, especially in the GPU compute department. Our goal is to provide every team a full A100 40 gig card. Right. So I mentioned GPU placement and this vGPU technology, and so this is kind of a diagram demonstrating what I was talking about. You can see on the left side here, you can imagine these colored squares, the red, blue, and green, represent an instance that was created by a different team. So the red team, the blue team, the green team. And in this case, this instance is a G3.large flavor. So a flavor kind of just dictates what resources a virtual machine or an instance get. How many CPU cores does it get a GPU? How much storage? How much RAM? That sort of thing. And so you can imagine there will be scenarios where if you're getting half of a GPU, you may have no neighbor like the green team down there, or you may be sharing a card with another team like red or blue. Whereas again, our hope for the final competition is to kind of eliminate that variability by giving you a whole card. Right. So storage. This is something that a lot of people are going to ask about. This is important. Um, what do we use for storage? So the default quota on Jetstream 2 is 1 terabyte, and that is allocated storage. So not necessarily files filling up devices, but this is an upper bound for how much storage you can allocate to various storage means. And we'll talk about those at the latter half of the slide. But if you feel like this is not enough, or if you feel like your team needs more storage, we do have some leeway, and you're welcome to request a little bit more via if you have a team liaison or via the Google group. It's important to note, I do want to mention big and bold, all storage on Jetstream 2 is networked. Even your instance's root disks that get created. So everything on Jetstream 2 is backed by our Ceph cluster, and so that's going to be your data is going to be sharded essentially across our cluster into objects, and so there's already kind of networking there. There's already kind of parallelism there, and so from our experience, you're unlikely to see many throughput gains by trying more advanced strategies by striping your data across your different instances or things like that. Although you're welcome to try if you have the expertise and if you do see good results. So the two primary storage media that you'll be interacting with or that you might want to choose for the IndySCC on Jetstream 2 are going to be called either volumes or manila shares. So a volume you can think of like a USB thumb drive or a flash drive. So these are devices that you can plug in, you can attach to a single instance at a time, and they give you raw block storage. Um, so because they give you raw block storage, they give you some flexibility to install or format them with whatever you want. So if you have a particular preference for a file system like XFS over ext4, you're welcome to do that. Um, the caveat again, though, is that they can only be mounted to one instance at a time, and so you're either going to have to shuffle that data around by, virtually unplugging and replugging them to different instances, or you can share it kind of externally by having a central instance, for example, running an NFS server. The other option is going to be something called a Manila share. So a Manila share in the cloud term is a networked file system that's totally managed by the Ceph cluster. And so this provides a POSIX compliant file system called CephFS, for which drivers are available for most major Linux distributions. And there's a Fuse driver as well. So you'll go in and you'll create this, and it gives you kind of ready to use network file system storage that can be mounted to many instances at a time. So if you're thinking of like what do we have in terms of easy options for like scratch space between a head node and compute nodes, that'd be a good option. And of course, Jetstream 2 does have a robust documentation page at docs.jetstream-cloud.org, particularly with storage. If you want to kind of read more about your options and their ins and outs, you can go there. Any questions so far? I know this is a lot of like walls of text and information being thrown at you. Cool. Right. So the next major topic that I really want to touch on is SU consumption. So, in terms of an allocated system like Jetstream2, we don't charge real money, but our kind of funny money or monopoly money is something called a service unit or an SU. And so, as a team, your particular allocation or project has a certain amount of service units budgeted, and every running instance, every running virtual machine will consume service units over time as it runs. The important thing to note, like if you take away one thing from this presentation, it's that the billing is based on the power state of your instances, not activity, right? And so if you have an instance that is running, it is occupying resources on a hypervisor, and the opportunity cost of that is that nobody else can use those resources because we statically partition cores and memory. Um, and for that reason, the full burn rate of an instance, say like if that particular instance type consumes 64 SUs per hour, that's based on the activity state or the power state, not the activity, right? So if that instance is unshelved and it's active and it's on a hypervisor, it is burning SUs, even if you're not logged in or even if nothing is running on it. And the mechanism to combat that is something called shelving. So a shelve action takes your instance and removes it from a compute node. It removes it from a hypervisor and it exists kind of in storage and metadata only. And in that sense, you're no longer occupying those resources. And so we charge a zero charge rate for that. So the important thing to know is that when you're not using instances, you always want to shelve them. When you unshelve them, all your data, all your configuration will still be there. You can think of it effectively like powering a server off or powering it back on to save on electricity costs. But again, if your instance is unshelved, if it's active, it is consuming service units. And the big change from last year is that this year teams have their own allocations, they have their own projects, and so you are going to be responsible for managing your SU budget, your allocation. Uh, don't run out of SUs. Basically, we're expecting every team to be a good steward of their resources, and each team has a level playing field in the sense that they all have the same amount of service units available to them. Um, so again, be responsible about shelving your instances when you're done. Again, powering off, so shutting off an instance or suspending an instance is not the same as shelving. The only way to stop SU consumption is deleting an instance or shelving it. I'll show you explicitly in a little bit how to kind of monitor your usage on an allocation. I'll show you in a minute how to monitor your usage, but it's important to note that usage on Jetstream2 is only updated once every 24 hours. And so you might not see the effects of something you're running updating in your balance in real time, but know that it might still be burning your SUs.
Hey, Zach, can I ask a question?
Yeah, go for it.
Yeah, so I want to make sure that I understand correctly. So when you create a new VM, it goes through the build process, and then it lands in the ready state. And there's like a little green icon next to it that says ready. When instances are in the ready state, it is burning SUs at that point, right?
Yes, yeah, totally.
Okay.
100%.
So, yeah, I guess for all the teams, as you create new instances, be aware that after that creation step, if you're not going to use them right then and there, that Zach, they should go to the shelved state, right?
Yep. Yeah,
Okay.
absolutely. So yeah, whenever you're not actively, logged in and using an instance, you're going to want to have it shelved. And again, I'm hoping to give kind of a live demo here in a minute. I'll go through the actual Exosphere page and I'll demonstrate exactly what you want to see. Any other questions? No? Okay. Cool. So now that you have your instances, now that you know how to manage your balances properly, you're being responsible with your allocation. How do you actually run stuff on these virtual machines? Um, the answer is however you want. Jetstream2 is again a cloud system, and we provide you virtual private servers. And so you do have full administrative access. You have sudo on these instances on these virtual machines. Um, and so you're free to install whatever software you want via your favorite means, whether that's your system package manager, you know, uh, like DNF or apt, or if you want to run containers, you're welcome to do that with whatever container runtime you want. You could use Aptainer, you could use Docker. Um, In terms of parallelism, again, there's no central scheduler for Jetstream 2, and so if you have multiple instances and you want to run a process across multiple virtual machines, you'll need to come up with your own solution or your preferred solution for doing that. And so that could take the form of, installing Slurm on your instances and setting up a cluster, and submitting that way. Or it could just be something as simple as manually running MPI run commands or using something like GNU Parallel. Um, an important note is when you're thinking about how to approach these problems, keep scalability in mind, right? When you're running on the kind of prep phase and when you're working on these practice assignments for the software you'll be working with and the benchmarks you'll be working with, you may be doing it across a handful of nodes, and so it's tempting to kind of configure things by hand, very manually. But keep in mind that when you get into that hero phase, for example, you'll have 24 hours to kind of bootstrap a lot more nodes. You'll have a lot more instances, and so you'll want to keep in mind how are you going to automate that? How are you going to program that? Whether that's something like configuration management, like if you have an Ansible playbook, even down to like Jetstream 2's cloud platform under the hood, OpenStack does support things like Terraform as well. Partial GPU flavors. This is an important note about running GPU software. The drivers. So partial GPU flavors, G3.large, G3.medium, and G3.small, which is going away, so don't worry about that one. Because of the vGPU technology we use, they do require a special proprietary NVIDIA grid driver. If you use one of our officially supported images from Jetstream 2, that will come pre-installed. Um, but again, if you don't, we'll need to set that up for you. The licensing terms for that from NVIDIA are pretty restrictive, and so we can't, for example, provide that package to Teams for you to install it yourself. Um, I would probably have to go into your instance if you choose kind of a more if you choose a more exotic operating system, which we'll talk about in a minute, there may or may not be support for that. There may or may not be a package supported for that. Um, and I would have to go in and install that manually, for example. But the important thing here is if you're using a partial GPU flavor, so less than a whole card, like a G3.large, don't delete the NVIDIA Linux grid package. If you do that, you're going to have a very bad time. So pay attention when you're installing like CUDA toolkits, for example, that you don't accidentally overwrite this driver with an off the shelf one because it will not work and you will break your instance. So I just mentioned things like operating systems and again customizability. If anybody participated last year, you'll remember that there was less flexibility in terms of being able to choose your own operating system, that sort of thing. But this year, we're hoping to give more freedom to teams, to choose what they want and what they prefer, what they're experienced in. And so there's more flexibility in terms of things like operating systems. Um, the important things to note are that if you choose something that's not officially supported by Jetstream 2 or officially published by Jetstream 2, we may not be able to provide support to you in turn because it's outside of our expertise or outside of our support area. So we can only guarantee support for the official OS images, which I'll show you in a minute. So those are Ubuntu 24 or 22 or Rocky Linux 9 or 8. Again, if you really have that gung ho spirit, if you really want to, you can provide your own image as a base for a virtual machine, for an instance, as long as it's generic cloud compatible. But again, support isn't obviously guaranteed. Other customization options are things like file systems. So again, if you have something like a volume or an instance's root disk, you can choose whichever file system type you prefer. But if you choose something that's more kind of specific or exotic, we may be able to support you less. Performance considerations. I mentioned in passing earlier that the IndySCC is a bit of an edge case for Jetstream 2. That is the truth. So Jetstream 2's primary use is kind of single node operations. So on-demand computing, medium workloads, interactive workloads, that sort of thing. And so large, massively parallel things are a stretch, or they're kind of they'll work totally fine. And we support that to an extent, but again, the system's not optimized for it. In terms of networking, like I mentioned, we're not optimized for low latency internode communication. So if you have two instances, for example, you'll probably expect to see a slight networking bottleneck bottleneck between those instances. For example, with like MPI jobs, that message passing will become costly. In terms of CPU and memory, cores are not oversubscribed, and so you don't have to worry about sharing CPU cores. Those are all yours. Those are statically partitioned. Um, though, as I mentioned, they may not be consecutively placed. So you may have slight variance in your core-to-core latency, for example. And unfortunately, that's just something that we can't change about the system. Memory is statically partitioned, not ballooned. So again, you don't have to worry about sharing that or about being constrained there. All the CPUs and memory on your instances belong to you and you alone. Uh, when you are testing with partial GPU flavors, so a G3 large, G3 medium, the vGPU technology under the hood does opportunistically use empty cycles on the physical card. And so imagine that diagram I showed where if you have half of a card that you're using, and you have no neighbor on that card who's running anything, you actually will get all of the cycles on that card. So you'll get all of the compute capacity, but that VRAM is statically partitioned. So again, if you happen to be placed on a card that doesn't have a neighbor, you may see variance in your performance on something like a G3 large because you may be getting those extra free cycles on the card. So this is the point where I kind of wanted to just go through the interface and show some basic things, highlight things. Before that, does anybody have any questions?
I have a question regarding the SU. How much computing I could have with that for one each SU point, or how much are we receiving in order to know that?
Yeah, that's a good question. So I think there were two kind of questions there. So one is how many SUs are you receiving in your allocation? You'll be able to see that in the interface when you log in. I don't remember the exact number off the top of my head, if I'm being honest. But the short answer to the other question, how much is an SU, is that one service unit is roughly one CPU hour. Um, so on things like GPU flavors, there will be a multiplier because of the extra specialty card there. But for CPU only instances, you can do the calculation. Of course, there's lookup tables. It'll tell you in the interface how many you're burning as well. But the calculation is generally how many CPU cores times how many hours is it active. Does that answer your question?
Yes, thanks for the answer.
Perfect. So I see another question in the chat. May I ask if vCPUs are NUMA bound to physical CPUs? The answer is roughly yes. We don't use hyperthreading, and again, we don't oversubscribe CPU cores. So one vCPU does correspond to a physical CPU core. Um, Again, though, the actual physical servers we have are dual socket platform, and your CPU cores that you receive on your instance might be spread across those two physical CPUs. Um, so I think the answer to your question is no. Any other questions or any follow-ups? Cool. So can everybody still see my screen now that I went out of the PowerPoint? I just want to make sure.
Looks great.
Cool, awesome. So this is Exosphere. So this is the primary and kind of easiest user interface for Jetstream2. You'll find it at jetstream2.exosphere.app. And again, you all should have your projects by now. If you're not already signed in, when you get to this homepage, you should see an add allocation button, and you can go through kind of the access sign-in process and add it there. But once you have it added, you should see a screen like this where you can select the allocation you want to work on. I'm working on this one, so I don't charge anybody's actual balances when I demonstrate stuff. Right. So as I just mentioned, on this home screen for your allocation, you can see exactly how many service units you have remaining in each category. So CPU and GPU do have separate balances. And again, these values right here are updated once every 24 hours when our accounting process happens overnight. Um, but you can see this allocation, for example, is larger, I think, than the ones you guys have at 1,213,000. But you would see a number here representing how many SUs you have remaining in your balance. And again, there's some information here about like the duration of the allocation, but for our purposes, that's not important. Um, right. So first things first, instances. Instances are the main way to interact with the system. You create a virtual machine and you run your stuff on it. So if you want to create a new instance, you would go up here to the top right and you would select this create button, hit instance, and then the first thing it's going to ask you is what do you want to create it from? So this by type section is going to give you options for base operating system images that are officially published and supported by the Jetstream2 team. So again, like I said, these include Ubuntu 24, 22, and Rocky Linux 9 and 8. Avoid Ubuntu 20 because it's old at this point and doesn't have GPU support due to driver conflicts. So let's say we choose Ubuntu 24. The next things it's going to ask you are things like, what do you want to name it? And again, these are unique to your allocation. So don't worry about naming it like login. It's okay if that collides with somebody else's. That doesn't have to be globally unique. You can also give it fun random names, but I recommend kind of more specific things. The next thing, like I mentioned, is flavor. So this is a flavor determines what resources an instance actually gets. And the naming convention here is going to be that like anything that starts with M is a normal CPU compute, so CPU RAM only. Anything that starts with a G is going to be GPU. We do have some maintenance going on right now, and we do have some extra things on this allocation that you may not see, because we do plan on restricting kind of what flavors you have access to kind of streamline things. But let's say that I wanted to make an instance with 4 CPU cores, and you can see the default for this is 4 CPU cores, 15 gigs of RAM. Those are not adjustable; those are non-negotiable for the flavor size. So if you want more RAM, you'd have to move up a flavor. But the root disk, I'll show you in a second, is so this default 20 gigabytes is just the default value for how much space you're going to get on your root disk, so your slash mount. If you just choose this default amount, it actually doesn't count towards your total 1 terabyte quota. And the way you can check that, by the way, is if you go to your allocation, for example, and you go to like volumes, you can see it'll show you your storage used. And in this allocation, we have 3.9 out of 5.9 terabytes used, but it would show you something out of 1 terabyte or however much storage you have. Great. So let's say I do want more root disk space on this instance. You can choose to actually back the instance with a volume. So the root disk of the instance becomes a volume, that storage medium we talked about. And I can choose whatever gigabyte value I want here. So let's say I want 50 gigs on my root disk. I can do that. You can launch multiple identical instances at a time, and it'll give it a naming scheme, something like name 1 of 3, name 2 of 3, whatever. Of course, you can rename them later. So this might be useful when you go to create like compute nodes, for example. You can create a bunch at one time. In Exosphere, there are some creature comforts, like there's an option for a web desktop, which is a VNC session in your browser. Ignore the workflow thing. This is if you have experimental features on. Let's see, 50 gigs. Let's have the web desktop. So the next thing is going to be an SSH public key. So when you provision an instance, you can choose to give it an initial public key to place in the user authorized key file. And the way you would do that is you would upload your public key to OpenStack to the cloud, and then you can select it here. So I'm going to select this one. Under advanced options, there's some more stuff like, do you want to install operating system updates as soon as the instance is launched? Do you want to deploy a piece of software called Apache Guacamole that gives you that web shell web desktop functionality? And then things like this, I wouldn't recommend messing with. Network, public IP address. This is something important to note, is that all of your instances, if you choose automatic, will get a public IP address. So a top level IP you could SSH to from your home computer. that becomes a little bit wasteful if you're using kind of an architecture where you have a login node, for example. What I would recommend is that if you have a login node, you can give it a public IP address. And then your compute nodes each don't need one because you can access them on the internal network from the login node. And the reason I say that is just because public IP addresses, of course, are a scarce resource. IPv4 addresses we only have so many of. So once you're satisfied with all your choices, you'd hit create, and then you can see this instance is building now. By default, this interface will filter to only show you stuff that you've created. If other people on your allocation have created instances and you want to see them, you can clear that, of course. And the same as with volumes. When you actually click into one of these categories, you'll see your SU usage here. So your balance kind of changes to an overview of what's called a quota. So this is going to be a maximum number of resources you can have existing kind of in parallel. So in this case, this project has an obscenely large quota. Yours will have a smaller one where I could create 230 instances. I could use a whole bunch of cores, a whole bunch of RAM, and this will show me kind of how many of those I've consumed already. And these are a running total, right? So if you have 2 out of 2 instances and you delete an instance, that goes back to 1. These aren't consumed. These are a total kind of maximum allowable at once. So this instance is building. It might build for a second. In the meantime, I do want to highlight again docs.jetstreamcloud.org. This should probably be your first stop if you have any questions about the system itself or about OpenStack or about how do I do X in the interface. My hope is that you can come here and kind of read through. We hope to have good documentation for most things. Like if you have a question about storage, you can kind of go here and scroll through. Another thing to note is there are other ways to interface with the system than this Exosphere web interface. So we do offer the default OpenStack interface called Horizon. That's at js2.jetstream-cloud.org. Of course, that link is in the documentation if you want to find that later. This is a more kind of advanced user interface, so it's not quite as friendly. And I have so many allocations that I can't even find the one I was looking for. but yeah, so this interface is not as friendly as Exosphere, so it doesn't give you a lot of those kind of easier interactions, but it's much more in depth. And so if you're an advanced user, if you're familiar with like the web console for something like AWS, you may feel more at home here. Where, for example, I could go through like all of compute, storage, identity to create like an application credential to use the API, for example, for something like Terraform. You would do that through here. And again, if I go to like compute instances, I can see a bunch of instances. This is a different allocation. So let's see, this instance should be done in just a minute here. They usually take a few minutes. I guess in the meantime, I can show you if you're interested in uploading your own operating system image, you actually can't do that from this interface, Exosphere, but you can do it from the one that I showed you, js2.jetstreamcloud.org, this Horizon interface. So for example, if you really prefer like Alma Linux for some reason, you could download their generic cloud image, go to this images section, and then you can create an image and upload that file, that if you have like a QCOW2 or like a raw disk file or something. Then when you go to create an instance, you could see it in this by image section. So this is a list of actual images. You can see these are the official ones, these featured ones, or if you had uploaded one, it would show up in this list. Cool, so it looks like our instance is ready. So this is what that page would look like. It'll show you some information about the instance. It'll give you a unique identifier, so a UUID. This is useful if you ever have any problems with your instance and you want us to support them. Be sure to include this UUID. It makes it a lot easier to find stuff. You can see who created it, what image it was created from. Sometimes it gets a little wonky with volumes. You can see what flavor it is, and then importantly, how many SUs per hour is this instance burning right now. So you can see this instance in M3.quad flavor. It's running, it's active, and so it's consuming 4 SUs per hour. You can see some basic graphs of like CPU usage, RAM, how full your root disk is. And then these bottom sections are how you're actually interacting with your instance. If you create it through Exosphere, again, you do get some nice creature comforts like a web shell, which is going to be a web interface through Apache Guacamole, where you can get a shell to interact with your instance on your browser. You can also get a web desktop, so this is going to be a whole VNC session inside of your instance. And again, if you don't want this stuff, you can turn it off. If you're really interested in optimizing performance, you can strip all this stuff out and really get it down to the bare bones. The console here is useful sometimes for troubleshooting. So the console button here is going to be something akin to if you had, a server in front of you and you plugged a VGA cable or an HDMI cable into it to actually interact with it. This is going to be your kind of terminal. You can see in this case, because our target is the graphical environment, we get the GNOME interface. But otherwise, if you had it set to just the usual multi-user or the command line, you would see your typical command line interface here. This can be useful for debugging, for example, like if your instance won't start, like it won't boot, you might be able to see more information in this console. Cool. The other thing here is credentials. So you can see each instance if it has a public IP address. In this case, this is the public IP address that was assigned to my instance. It does get a DNS record as well, so you could SSH to this login dot, and then your project name .projects jetstreamcloud.org. And then if you created your instance through this Exosphere interface, it will get a default user called exouser, and it will get a passphrase provisioned to it in case you didn't upload an SSH key. In my case, I did, so that's well and good. So I could go onto my computer and I could SSH exouser at my IP. If you didn't create your instance through Exosphere, of course, the user would be not exouser, but just the default for your distribution. So Ubuntu at IP or Rocky at IP or whatever yours is. We can see what volumes are attached to an instance here. We can attach new ones. So if I want more block storage, so say that this is just, I want extra scratch space on a login node for like, doing whatever, I could attach another bigger volume here that's not necessarily the root disk and have that external storage. The other thing I did want to show you while I'm in the Exosphere interface is before we go through like shelving and everything, Manila shares, because I did mention them. In order to access Manila shares through Exosphere right now, you do have to go to the settings option and enable experimental features. It'll be promoted soon, but for now it's an experimental feature. So if you do that, you'll have a new section here called shares and a new option under create called share. So when you go to create a Manila share, unlike an instance, this name does have to be globally unique. And so you'll want to give it, and when I say globally unique, I mean it has to be unique on the entire Jetstream2 system. So if somebody else on the system already has a share called login, you won't be able to create that. So I recommend doing something like, a unique identifier like IndySCC and then like a team number or something, and then like the name that you want for it. You can put a size. The size can be adjusted later. You can extend it if you run out of storage, and then you can give it a description. I'm going to go ahead and create it. You can see this is our newly created share. And then the fun thing here is that Exosphere will create a read write and a read only credential for you, and it will give you a convenient way to mount it to your instance. So if you want like the read write, for example, you can copy this script and then go back to your instance. We'll see if the copy paste actually works here. Maybe not. Oh, there we go. So you can see it mounted this share at /media share IndySCC 123 login, and we can see we have our 10 gigs that we just created available at that location. So of course you could run that script to mount this share to multiple instances at a time. Or you can do what I'm going to show you in a second, which is imaging. So let's say that we have an instance that we really like for example, we created a compute node and we installed a bunch of stuff on it, and we really like the configuration on it. We have important files that we really want to keep across all of the instances that we create. What you can do is you can go in this interface here and you can select actions, and then you can choose to image your instance. So this will create an image that you can use as the base for another instance from your currently running one. So if I go in here and I click this image button, you can name the image. Oh, and then of course it doesn't work because stuff is broken. You do usually want to shut down the instance before you image it, so I am going to do that. Uh, Anyway, again, if you create that image, the next time you go to create an instance, you could go here when you create the instance, go to image, find the image you created, and create it from that. And what you would find is that all the configuration and stuff you had done to that instance persists to the new one. So that includes like the files you created, the software you installed, and like if you had mounted that share, for example, you could mount that share to one instance, image it, and then create new ones from that image, and that share would be mounted automatically as soon as the image start or as soon as the instance starts. Um, in this case, I'm not going to wait because we're low on time and because nobody wants to sit here and wait forever. But I do want to show you again, the most important thing is you can see this instance is burning 4 SUs per hour right now, um, even when I'm not logged into it. And so when I'm done working on this instance, what I want to do is I want to come up here and hit actions and then shelve. You can choose whether or not to release your public IP address while it's shelved. If you choose to do that, you'll get another one when you unshelve it, but it might not be the same. So if you want a consistent IP address, I would recommend unchecking this box. So again, shelving your instance, you can think of like shutting it off. Even though shutting off is an option, it's different because your instance is still scheduled on a hypervisor. It just happens to be turned off. Shelving actually removes it totally from that hypervisor, and you can see for an instance like this, it's pretty quick too. And now that this instance is shelved, it's consuming 0 SUs per hour. And so your kind of method of managing your allocation is really going to you're going to want to go through your allocation and make sure that things are shelved, that they're not consuming any SUs, that they're not burning any SUs. I think that about covers all the important stuff I wanted to go over. Does anybody have any questions about Jetstream2, about the IndySCC, anything at all? Cool. In the Google Groups discussion, the committee said you will have enough SUs available during the final competition that you can run all the allowable instances. Does that mean that teams don't have to worry about? Yes. Yeah. So the idea is that for the final competition, your balance will have enough that you don't need to worry about having stuff shelved and unshelved all the time. You should just be able to run all your instances and have them going. Um, due to the nature of that, we kind of expect people to be running stuff constantly.
And that goes for the hero run phase as well, where you have just 24 hours. And Zach, I know that you mentioned this, but can you just repeat for everyone, if they have a question about
Yeah,
Jetstream2 resources, how should they get help?
that's a great question. I have a slide for that coming up next. So, where should teams get help with Jetstream2 resources? The number one place to ask is the Google group. And so, we do ask that you ask there first, and we'll kind of act as a proxy to Jetstream2 support and committee members. We ask that you please, again, like Layla said, try to avoid contacting committee members directly unless your question is sensitive in nature. And again, just asking the Google group and somebody will get to you. Again, docs.jetstreamcloud.org is going to be your best friend when it comes to Jetstream2 stuff and getting help with the cloud itself. And I'm happy to publish these slides as well if we can share them out in the Google group.
We can do that. We've also, Zach, been adding all of the I think a PowerPoint or a PDF to the website. And so the
Perfect.
recording of
Yes.
this webinar will be on the IndySCC under, I think, informational webinars. There's a little drop down there that expands to show all of the recordings and copy of the slides.
Perfect. Awesome. Yeah. I mentioned that because I know a lot of the time people get mentioned a URL and then it goes in one ear and out the other. Then 2 weeks
Yep.
later, you're like, oh man, what was that URL again? I wish I had that somewhere.
Yep.
Awesome. Yeah. So Google group first. Please ask your questions in the Google group. Somebody will get to you. I swear that's the last slide I have. I do have one more. If there are any questions.
All right. I'm not seeing any raised hands, any additional questions in the chat. So I think we can let everyone go. And yeah, any questions, please post to the Google group.
Perfect. Yeah.
Right.
One last ditch effort is an advertisement for Jetstream2 outside of the IndySCC. If you're based in the US and you need computation, if you need interactive computing, Jetstream2 could be the solution. Jetstreamcloud.org.
Awesome. I love the plug. Thank you so much, Zach. And thanks everyone for attending. Have a good weekend.
Have a good weekend. See you.
Bye-bye.